Welcome you to the next session of embedded software testing, Unit 2 testing methods, lecture 18 series of this Unit 2. Today we will go through some of the testing techniques in terms of white box, and in our yesterday's session we had discussed about model based testing. Is another software testing technique. So advantages we had seen, and we took a sample model as a notepad, and how we can generate the test cases for each of the model represented elements, and then the testing. And we also understood about the tasks that are required for doing the MBT, model based testing. And we had seen some of the models in software testing. Simplistic approach we have studied in terms of a calculator as an example. Then the flow that can have for the model calculator also we understood, and the feature wise or the functionality wise testing of the MBT also we listed out in terms of scenarios as well as the functionality as aggregation, application, node, display, etc. Taking in a calculator as an example. Then we listed out the classes that are required for the test model, like model itself, test generation, test execution, test evaluation, and the categories of those classes, like in terms of test selection criteria, technology, execution options, specification, and test technology for testing evaluation of the tests that is being carried out, and what are the options that are there for doing all these activities that are listed out under the categories that also we had seen. Okay, so today we will discuss about white box testing technique. Before that, I will just touch base on some of the dynamic testing aspects which we had a session some time back. Okay, so dynamic testing, basically the testing done at real time or during the execution of the testing. Embedded software testing is called dynamic testing. It is basically divided into two groups, white box and black box. So there are various techniques for black box, there are various techniques for white box. Okay, so why we need black box and white box testing techniques? Because the software under test or the unit under test needs to be tested at different levels. So we need to test as a function, as a complete black box running on the field or at the real time or from the user perspective. That is why we use the black box approach, where the internal details will not be known. Whereas in the case of white box testing technique, we will go through the internal structure, algorithm, code, or implementation details of the software under test. Then we will do the testing technique. Okay, so basically we need to have a strategy for testing. What is the purpose of testing, the goal, how to reach that goal, all this have to be laid out. Then once we have these details, we are going to have test case selection methods. That means how we can pick the test cases for each of the requirements of the functionality, which scenarios need to be combined together so that those scenarios can be executed in one shot. So all test cases representing inside the group also need to be done while doing the test case selection. Then we are going to come up with a coverage, how much of the functionality requirements we have covered. So in terms of black box testing, we go for the requirements coverage. In terms of the functionality coverage or the features coverage, whereas in white box testing we go by the code coverage. Okay, so black box and white box testing, test case selection methods, black box, functional or data driven, basically based on the requirements, function specifications, interfaces, system specification as per the need that we have for the software under test or the system under test, embedded system under test. Black box test design techniques are based on the functional behavior of systems without having any explicit knowledge of the implementation or the code or the structure or the logic inside. In black box testing, the component is subjected to input and the resulting output is analyzed whether it conforms to the expected behavior. So we have all the external input in terms of a signal, it could be a discrete, analog, whatever it could be. So all these will be driven and we see the behavior of the system resulting in an output, and that output will be analyzed whether it is conforming to the expected behavior as per the conditions that is being specified in the specification. In the white box or the structural testing, it is also called logic driven testing. It is purely based on the structure of the code or the implementation. White box test design techniques are based on the knowledge of a component's internal structure and uses all the information about how the inside of an unit works. That means we will be knowing all the details that is there as part of the embedded software. Each and every components and the units will be understood in terms of doing the testing. This information might be a code and design. Of course, for understanding the code, it just may not be enough to go through the code. So we need to have a design aspects as well. Understanding a thorough design aspects is very important, because without understanding the design, we may not be able to understand the code. So there are different types of design, like high level design, low level design, and low level design is most likely to be very near and mapping to the implementation or the code. So that will be studied and understood before we do the white box testing. So white box tests ensure that each implemented statement is run at least once and tested against correct behavior. So we will study about what is the statement based testing, decision based testing, coverage, and all that aspects in the today's and next classes. So basically, white box testing will be the internal details testing in terms of statements, structure, and all that. Okay, here is a diagram which gives a fair idea about how a system can be segregated. So we have component test, integration test, system test, acceptance test as one side. As we go along for the testing, at a higher level we do system test and acceptance test, and at the intermediate level we do the integration test, and at the component or the unit level we do the unit testing. So the one that we do at the component or the code level is nothing but white box. Of course, integration test can also take credit of this white box, or white box testing or the unit testing can take some credit of integration test, where there is a challenge in terms of white box, where which we cannot cover with the help of white box. So integration test results will be considered in that case. Black box is of course purely based on the system test and partially based on the integration test also. So these two are basic techniques. Of course, there is one element called gray box testing, which combines both white box and black box techniques. So mostly gray box testing, there is an application domain, not in embedded systems or complex systems, but it again depends on how you want to take up. Mostly they deal with white box and black box. As I said, the coverage is very important, because we need to report the testing along with the results with a coverage aspect. Like we need to cover the functionality and we need to cover the code. So white box testing deals with the code coverage. So what is code coverage? Code coverage in a nutshell is as simple as total number of executed code divided by total number of code that is there. So we measure this in percentage. Similarly, for black box testing, we use the requirements coverage in terms of total number of requirements tested versus total number of requirements available. So that is the percentage it gives for coverage. Okay, so differences between black box and white box testing. We'll just glance through this. It is also called as input output driven testing or specification based testing. Here it is also called as logic driven or implementation based testing. Implementation is nothing but the code. Software is viewed as a black box without bothering about the internal behavior and structure of the program. Here permits to analyze the internal behavior and structure of the program. Software is tested against its specifications, whereas the software is tested against low level specification or low level design with knowledge of code. That means code and low level design both are used for doing the white box testing. Test data is derived solely from the specification. That means the inputs and the outputs are derived purely based on the specification, whatever it specifies. Here test data is driven or derived from the logic of the program, how the flow is there. It's also called as a control flow, and another term they use it as logic flow or data flow. So these two are basically used. Here also there is a control flow, but purely from spec or the requirement or the functionality. Here the flow is purely from the structure or the logical blocks, I would say, of the intended code, intended system behavior, whatever you would like to call. So these aspects will be done in white box testing, the control flow and the data flow, whereas the control flow and the signals are used for testing the system with the help of requirements and specifications is nothing but the black box testing. Okay, so black box has its own advantages. The black box tester has no connections with the code. We don't have to care about the code. So always he look from the perspective that code should have some issue or the bug. So in that way he will test it. Test cases are designed as soon as the specifications are complete. So no need to wait for the implementation to be done. So you can go ahead with the test plan, test cases and all that based on the requirements. The implementation could be still in progress, but he can go with the test planning, test case scenarios generation and whatever the high level testing is needed. So there is a need of high detailed functional knowledge of system to the tester and its behavior. That means we should have a sound knowledge of the system. It's very important, especially during the black box testing. Tests will be done from a end user's point of view, because end user should accept the system, and this is the reason sometimes this testing technique is also called as acceptance testing. That means from the user's perspective or the customer's perspective, it's very important to understand the whole system, and accordingly the tests have to be written and tested so that the product can be released as a defect free product. And black box testing helps to identify the ambiguity and contradictions in function specifications. That means while writing the test cases or executing it, we will know there are issues in terms of the system specification itself or the functional specifications, because there will be some requirements which are contradicting to the other requirements. Some requirement says this way it should be triggered, whereas the logic that is detailed out in other requirements may be contradicting to the primary requirements. So all this will be brought out because especially this will happen when we deal with the complex systems where multiple teams are involved and there is some sort of a understanding issue or some sort of a errors that would have been injected while writing the spec. Efficient is the black box testing is very efficient, especially on a larger and complex system, purely because we approach the testing technique in a larger view or the black box view, and it's better because just testing the code may not be enough, or it is really not enough because some of the end product issues or errors or bugs need not be or will not be found with the help of white box testing. Okay, black box testing disadvantages are testing with every possible inputs is very difficult because all signals and its uh, ranges or the values may not be able to feed. It's very difficult and it's tedious also. And all test cases we may not be possible to execute. We have seen that partition equivalence and boundary value analysis and all that in our previous classes. So all we need not have to do, but we should have a nominal range in between, which is enough. So that is subjective to the availability and applicability. So black box testing don't care about the structure and design coverage. Uh, no knowledge of code basically, but its advantage as well as its disadvantage. Sometimes some of the low level details like target based hardware, registers, timing, performance, etc. He may not be having a proper knowledge. So it may be very important to understand that also for doing the black box, but white box will definitely bring out all those aspects. Another problem is that when doing a black box testing, if an error or a fault is found, it may not be possible to isolate where the problem is. It may be anywhere in the code, which is difficult while doing the black box testing. Whereas in terms of white box testing, we know what statement has fallen into an issue. And for isolating this, white box testing somewhat credit we may have to take, or some sort of a code inspection and analysis may have to be done for detecting the fault code. Reasons for intermittent failures of the code cannot be determined. That means sometimes a failure comes, sometimes the failure may not come. While doing the testing is very challenging testing aspect. It is called point-to-point testing. Then you just verifies whether user required functionality is implemented exactly or not. So while doing that, intermittent failure could be there. It's very difficult to isolate due to what that failures are coming. Though on a nutshell, while doing testing at black box level, it appears to be a simple failure, but that failure should be able to reproduce. This is one important term that is being used. Reproducibility. That means we should be able to reproduce the issues that we found during the black box testing. So that reproducibility is an important aspect, and all the cases mostly it should be reproducible, but one or two cases or few cases it may be difficult. Those are called intermittent failures. So those things are a bit challenging, but with the help of white box we may overcome those problems. Some of the errors may not be able to discover until white box testing is done. So we know that there are issues, but until we complete the white box, we will not be able to discover it. And test environment is very important, and we have a heavy dependency on that, and the system should be stable. Then only the black box testing can be done effectively, because the black box testing as a whole, it is done on the entire system, and the entire system should be running under all the conditions that is intended, and those conditions are having a dependency for carrying out the tests, and it should be stable and running all the time. Then only we can conduct the black box test. Okay, white box testing advantages. As the knowledge of internal coding structure is prerequisite, it becomes very easy to find out what type of input data can be used in testing the application effectively, where the problems are, and each statement or lines of executable, the tester will have a knowledge. So with the help of that, he should be able to churn out where the problem is. Helps in removing the unwanted lines of code which can bring in hidden defects. That means there are certain lines of code which can be optimized or which can be removed as a defect, because it will be hidden inside, and we can improve the implementation with the help of white box testing. Helps in determining the fault code segments. That means, as I said, the lines of code when we do a statement with the white box testing, if the user has implemented wrongly, suppose instead of equal to, if he has used double equal to, the meaning is entirely different. Whereas the first one is for assignment, the second one is for comparison. So the purpose of that line varies, and the fault is already existing. That is how white box testing will bring out all this faulty code which is implemented. Discrepancies between the code and the requirements can be identified accurately. That means white box tester will have a knowledge of requirements as well, and while going through the code and testing it, he will have a in back of his mind the requirements, and with the back of his mind having requirements, he can definitely know where the problems are, and discrepancies we can find out easily with the help of a code and the requirements understanding with an with an accuracy, and no much system dependency unless there are signals that are derived from the external system. That means he doesn't have to care about the external signals. Suppose some unit he is trying to test, there are few parameters which are derived from the external system. He don't have to trigger the external system. Rather, he can feed the values by himself, whatever the expected values that signals are supposed to take. So those are some of the white box testing advantages, and we go through the white box testing disadvantages. As knowledge of code and internal structure is a prerequisite, a skilled tester is needed to carry out this type of testing, which increases the cost in general. That means we cannot afford to have a shufflement of the team again and again. Person should have a thorough understanding of the code. We should have a good knowledge of the code as well. So, that is the prerequisite, and a skilled tester only can do this, where he has a knowledge of the underneath the language and the underneath the compiler or the target where the code is being used along with the system as well. But more emphasis is on the internal structure and the logic of the code, and it is time consuming as to test all the aspects of the code. It means if there is a 1 lakh lines of code is there, all the lines of the code need to be tested. So it's a bit time consuming as well as a lot of effort required, and the cost is required in terms of ramping up the team, and uh, putting the right effort, right schedule, and all that. Covering structure of code and its implementation as preset standards. At times, there is a need of system knowledge for the internal details of the implementation, especially the tolerances, states, etc. That means it is not enough to have just the internal structure and the code knowledge. We should have a knowledge of the external signals and the system and the states at which the system behaves and the transitions. All these details you need to have. Okay, so that is the background of white box and black box testing, and we focus on white box because black box testing we have covered, like partition equivalence, coverage analysis, nominal range, and all that. Okay, now we will touch base on the coverage testing. Okay, so having understood black box and white box testing, we will go through white box testing technique, the internal structure, logic, and all the aspects of the testing. We will go through. So the basic idea of white box testing is to test all the internal structure and the logic and the implementation that is there in the system. So there are different types of testing available. Let's try to understand that. Okay, coverage testing. The weakness of functional testing, that is the black box testing, is that it rarely exercise all the code. Coverage tests attempt to avoid this weakness by ensuring that each code statement, decision point, or decision path is exercised at least once. Coverage testing also can show how much of your data space has been accessed. That means we have a flow, logic, and decisions. The logics having decisions and controls. So all this may not have been exercised in black box testing or the functional testing. So how do we do? So with the help of code, we will do that white box testing. All the aspects of that code that is there in the statement and the decision points like if else, while do, cases, all those will be tested. The decision points and the condition points and the decision paths, all this will be covered in coverage testing. That decision logic can have basically derived from the flow charts such as if else, while do, processing. Processing we have, then case. I'm taking example. It doesn't matter which language we are using. C, ADA, C++, whatever it is. We come across all these decision points, statements, and logics, right? So these blocks will be basically exercised to make sure that all these blocks are covered and the statements underneath these blocks or covering all this will be exercised. So that is where we have a weakness in the black box testing or the functional testing because we test the whole function, not addressing every path that is underneath that. Also known as white box tests or glass box tests. Some people say glass box test, but we call it as white box test. Coverage tests are devised with full knowledge of how the software is implemented. That means we should have a full knowledge and the control of the code. That is with the permission to look inside the box. It means purely it is internal structure of the software. It is also called structural coverage. It's a very important term where the complete structure of the implemented code is exercised to make sure that there are no defects. So that is why it is called as coverage testing. And why is white box testing? White box tests depend on specific implementation decisions. They can't be designed until after the code is written. It means testing design technique we need to have after the code is implemented. So those are some of the coverage testing aspects that need to be done in white box testing. Okay. So what are the broad level coverage testing elements that are there? As I said, three types of coverage we do in terms of coverage testing. They are statement coverage, where test cases selected because they execute every statement in the program at least once. Minimum one time the statement have to be covered. So that is where we use statement coverage. And other broad level categories, decision or branch coverage. These test cases tests the every branch. That means we have a decision, right? Like if else, so if else can have true path as well as false path. So both have to be exercised, and that false path can have again some more decisions. For example, uh, let me see if I can draw. Okay, there is a decision box, and suppose statement is there. Uh, compare something, compare a signal against its range. Suppose a temperature. So we'll do the decision taking care here, whether it is signal is true or false, or signal less than some value. If it is true, this path will be there. If it is false, some more statements are exercised. It could be another decision box further down the line. Again, we'll have to exercise leading to multiple paths. It could be another true, another false. So basically, we need to exercise this, this one path, this, this, this again. Likewise, it will go. The flow will go. So all this, because there are number of statements for true, number of statements implemented for false, and again we have a decision underneath that. That decision also will lead to couple of paths in terms of true and false. So all these have to be executed at least once while doing the statements coverage. That means we do the statement coverage, each of the statements. Along with that, we are covering the decision or branch coverage. Another one is conditional coverage. What we do here is test cases chosen to force each condition in a decision to take on all possible logic. Suppose this is instead of this less than 30, one more condition also is there. Suppose signal less than 30 and greater than 20. So there are number of cases which we can derive. So that could take another path. Instead of true false, do this statement 1, here statement 2, statement 3. Likewise, we may have different conditions that is existing instead of a decision and branch. All these have to be exercised, and all the logic values that needs to be taken care of, like less than 30, greater than 20, greater than 30, less than 20. Like we have seen boundary how we do for black box testing. Same way is applicable for here also, where all possible logic values are taken. So this is another type of coverage we have. So basically, three broad categories: white box as statement, decision, condition. And to achieve statement coverage, every executable statement in the program is involved at least once during the software testing. Achieving statement coverage shows that all code statements are reachable. This is especially very important because there are standards like DO170 that mandates this. That means 100% coverage is mandatory. Statement coverage 100% is very much required. Maybe I'll brief one of the session about DO170, which is an aerospace standard. %100% statement coverage. Of course, there are different safety levels like A, B, C, D, E. 5 safety levels are there in DO170. Based on the level of safety, the decision is taken at to see what sort of a coverage we need to have for testing, white box testing especially. That is how one of the standards says. Similarly, we have AutoSAR and others that are used in automotive. So basically, to cover the statements that are getting executed. Okay. So white box testing, in other words, what are the types of white box testing that we have? So we have statements testing where all the statements are to be executed, and we have a branch decision testing where each decision path and branch path that are need to be tested, and we have a data flow testing where the data that flows within the embedded system need to be tested in terms of all possible values, and the branch condition testing where the branch leading to different conditions need to be tested. Then we have branch condition combination testing. I will put the different slides and we will detail about all this in a separate session. And we have another one called modified condition testing. It's also called as MCDC, where there is a truth table. They write it for all the possible conditions. Sometimes we may not be able to test all of them, but it is again subjective to the level of safety and level of justification. Based on that, we may have to go. The last one is linear code sequence and jump testing. This is another technique that is being used. Okay, so we have seen black box, white box testing. In terms of white box testing, different methods: statement testing, branch decision testing, data flow, branch condition combination, modified condition, and LC SAG. Having said this, we will take the first one as statement coverage. So what is the statement coverage testing we do? Okay. The idea with the statement coverage is to create enough test cases so that every statement in the source code has been executed at least once. That means execute every statement in the code at least once during the test case execution. While we do the test case execution, all the statements in that module or the unit has to be executed, or it should touch that whatever the test path that it is going to execute. requires use of tools because manually it may be difficult to do it. There are a lot of tools. With the help of that, we can do this statement coverage testing. The tools, I will list out the tools, specify that what those tools are used in the industry, such as LDRA, VectorCast, RTRT, etc. Basically, what they do is they have test hooks added to the existing software. That mechanism is called instrumentation. Instrumentation skews performance. That means instrumentation of the existing software in such a way that all the statements should be executed at least once. With the help of that tool, we will be able to do. The workflow when using the statement coverage is to first execute all existing black box test cases. That means basic normal in terms of the functionality test cases uh, that are created while monitoring the execution. This monitoring is all but the simplest test cases performed with tool support. It means a normal test behavior with the basic flow of the functionality will be tested. When all the black box test cases have been executed, don't get confused with the black box and all that. What I'm trying to say is, normal cases where we exercise the functionality of that particular module or the unit, that will be exercised first. So the tool, same tool will be used where being used for white box to generate the test and execute it. So the tool will report which parts of the code that are not tested. So then we are going to add those additional untested area in terms of the lines of code. So the idea is now to construct new test cases that will cover as many of the remaining statements as much possible. So start with the part of the code that should be reached, walk backward in the code to determine the values of the input variables required to reach the desired part of the code. With the specified values of input variables, check the specification for expected result and execute the new test case while monitoring it. That means we may have to do back and forth in terms of reaching the code. So how we can reach the code? Maybe could with the help of the inputs that are required. So the inputs to reach all the code will be through uh, the data driven within the code. That data driven aspects could be a parameter because we use a function which has parameters. So these parameters will be triggered such a way that all the statements with the possible flow of the executable statements which are not reached with a normal functionality will be covered. So that is why we use statement coverage. And the expected result, how to expect is basically there are functionality wise requirements for that module, what it is supposed to execute and what is the output of that. So based on that, we will set the expectation and the expected results. Those expected results will be monitored while doing the statement execution with the help of this instrumentation. The instrumentation is done by the tool for the white box, but the white box, the tool, we need to configure it or uh, modify in such a way that all these aspects in terms of normal functionality as well as complete statement coverage needs to be done. One problem that I have seen is the expected result should not be from the code. That means we should not see the code in terms of expected result. We should see the functionality of the code that is being executed. That should be taken or considered as an expected result while exercising that basically. Of course, if it is a individual statement having a localization, aspects, then we can use the code itself as expected result. But most of the case we may not be able to achieve because the code is supposed to deliver the required output based on the functionality, and you see or dig more into the code, the tester may get biased. So first he needs to understand the system with the help of a specification. Then that specification he should match with the connected modules that are underneath each of the functionality, and that each functionality he should try to drive the different inputs, and each functionality he needs to provide an expected result of the behavior in terms of its functionality. So that is how we will be doing the statement testing. And statement testing is done with the help of instrumentation, and the instrumentation is mostly done with the help of tools. And the coverage, how we are going to achieve is statement coverage, how much we have touched, that means how much we are able to execute statements, and against that total number of statements, this will be in percentage. So we are supposed to have 100%. Sometimes it may not be possible to reach 100%. So it could be 90 or 95 percentage, etc. So whatever that 5% leading to not covered statement, so we may have to do additional testing. So additional testing could be with the help of code inspection or analysis, whatever it is. So those will be used for achieving the 100%. Sometimes say some statement in the code may lead to an interrupt, and that the interrupt may not be able to achieve with the help of instrumentation or some register checking or register operations. Those things may not be able to do with the help of a tool or offhand with the model itself. There is a dependency on other things. Those aspects may not be able to cover. Those aspects we should be able to do with the help of debugger, analysis, or inspection, whatever the possible alternates that we have for the statement test. So that is about statement coverage. Probably I will try to explain with an example of C code in the next class. And there are other white box testing techniques, and there is a C code you see here. Example code, we'll try to see that. There's a while statement, there's a if statement. So all these inputs need to be triggered for statement coverage so that all the statements are executed. Suppose if the count takes less than iterations, and iterations is here how much, 750. So we should be able to execute all possible 750. This will not be done manually, but with the help of a tool it will be done. Okay, now coming to statement coverage testing or the coverage testing, we use the term called instrumentation or the software instrumentation. So what is instrumentation means? So software only measurement methods are all based on some form of execution logging. It means we measure the software in terms of execution only. How much software is executed is what we measure in terms of software testing. The implication is that after the block is entered, every statement in the block is executed. So by placing a simple trace statement such as a printf at the beginning of every basic block, you can track in the block, and by implication all the statements in the block are executed. That means we have suppose 10 statements in a block or a functionality or a module function. This suppose has statement 1 followed by semicolon, semicolon is a executable terminator. Okay. So 3 statements are there. how do we know that each statement is executed? So we can put a trace. The trace could be anything, but the tool uses a different tracing mechanism. As a simplistic approach, we can use a printf, so that by seeing the report, if I have a three printfs printing some values for each of these statements, I know that three statements have been executed. So that is the funda about the implication of each of the statements in this functionality or the block. And if the functionality has several hundreds or thousands of lines, it is not practical to have inserted the printf by ourselves. That is why I told this process is called instrumentation. This instrumentation is done with the help of a tool. There are a lot of tools which does all these traces. If the application code is running under the RTOS might supply a low instruction logging service. So sometimes RTOS itself will provide for trace in terms of the statements. So if that is there, then a trace code can tell RTOS at the entry point of each basic block. The RTOS can log the call in a memory buffer in the target system or report it to the host. That means RTOS will have a functionality to see what are the statements that can be traced or not traced, etc. The feature or the functionality is available within the RTOS that can be used for tracing out all the statements within the block. But mostly non-RTOS embedded systems, they use instrumentation aspects with the help of a tool. Okay. And even less instructive, intrusive form of execution logging might be called low intrusion printf. A simple memory write is used in place of printf. It need not be printf. Printf basically, depending on the IO that if we have, it will print the value, or we can use a memory write where we will write into some sort of a memory, and that memory can be dumped to analyze, or instead of a memory, we can take a report in terms of printing it into a Aristotle or any output that is connected, so that the less intrusive form of execution can be taken care. At each basic block entry point, the login function marks a unique spot in excess data memory. After the tests are complete, external software correlates these marks to the appropriate sections of the code. Alternatively, the same kind of logging call can write to a single memory cell and a logic analyzer. We will speak about logic analyzer in a later section. I will tell what it is. There is a hardware interface, as I said, RS-232 or CAN or any of the interfaces. We can use it for logging the traces, for covering all the statements. If upon entry to the basic block and the logging writes the current value of the program counter to a fixed location in memory, then the analyzer set to trigger only on a write to that address can capture the address of every login that is executed. After the test suite is completed, the logic analyzer trace buffer can be uploaded to the host computer for analysis. This is what I told. The logic analyzer sort of a tool is used to check the traces and log the execution. So this method or the process is called software instrumentation. If the system being tested is ROM based and the ROM capacity is close to the limit, the instrumented code image might not fit. So this is an interesting thing. I will explain. If the embedded software fits to the flash or the memory in the target base, right? So what will happen is sometimes after the instrumentation code that size may exceed. So what we can do is we will reduce the functionality and test only the pieces of the blocks, and we will do multiple iterations to cover it. So what we can do is we can improve your statement coverage by using two more rigorous coverage techniques: decision coverage and modified condition coverage as a next technique basically. Okay, so there are other aspects of testing, gray box testing and coverage testing tools and all that. We will see that in the next session. Okay, We'll go through some of the words that we have used. Uh, Additionally, I think after MBT we have a coverage, statement, lines of code, instrumentation, etc. So these need to be studied. Of course, we will have some of the glossary, initial state, system state in which the first event is accepted, input, input domain, input value, inspection. Inspection we'll study in the next future session. A group of review quality improvement process for return material. So we do inspection of the existing thing. It's a process. Integration, we know, combining different components into larger assemblies. It could be hardware software or software software. The integration strategy will work out addition about how the different combinations can be integrated. Integration testing is performing the integration. Iterative development, an iterative life cycle based on successive enlargement of and refinement of a system through multiple development cycles of analysis, design, implementation, and testing. So we have seen in the life cycles, V model is used. Similarly, iterative development is also another life cycle model that is being used. Known errors, that means defects that have been found but not solved. That means we already know the problem. With the understanding that this known, with the known defects, we will go ahead with other known, other unknown issues. Life cycle structures the process by dividing it into multiple phases. Lito we have seen, it's a TM method where 4 cornerstones of structure testing is used. Lito means life cycle, infrastructure, techniques, and organization. So that is about the class lecture 18 as on date. We will continue the white box testing in the next class.